Svetlana Yenikeyeva. Maybe we shall start the first presentation. Иван, вы меня слышите? Иван, do you...
Yes.
Shall we start? Yes.
Yes.
Yeah.
And announce the first presentation.
Dear colleagues, who is the first?
Yes, the first presentation is computational. The first report is computation and analysis of two-phase filtration using average models in oil formation with both vertically stratified heterogeneity and horizontal zonal heterogeneity. Who is the presenter? Svetlana Yenikeyeva, isn't it?
Yes, we are going to present this report. Yes, can you share the screen? Демонстрацию экрана нам разрешите? Can I start?
Yes.
Computation and analysis of two-phase filtration using averaged models in oil formations with both vertical stratified heterogeneity and horizontal zonal heterogeneity. Сергей Плохотников, Светлана Yenikeyeva, Дильбар Бекмухаметова, Quanto, Kazan National Research Technological University, Kazan. Mathematical problem statements in aeromechanics, hydromechanics, filter theory, and others are based on general theorems of continuum dynamics. They are determined by sets of equations of the second order in partial derivatives of elliptic and parabolic types with boundary conditions of the first and the second kind. In some cases, hyperbolic equations are used. In numerical implementation of practical problems in oil and gas field development, one often deals with averaging physical parameters of equations of a three-dimensional system, and with transition to averaged mathematical models of lower dimension. Lower dimensional models are also applied for solving the problems of wave propagation through random media, particularly in atmosphere and ocean. Medium heterogeneity can be taken into consideration using methods of averaging. In the process where averaged medium characteristics depend only on vertical coordinate, the task is significantly simplified. For oil and gas fields with layered heterogeneity by absolute rock permeability, this computation is of practical importance. It is especially notable when heterogeneity is set by for both thickness and strike, which is determined by physical structure of some multi-layer formations. Absolute permeability function of porous medium in general terms for such formations can be represented in a multiplicative way by the formula. The formula is on the screen. Absolute permeability of each vertical layer in such oil formations is set by the following formula, where K of X is an average value of oil formation thickness of a zonal heterogeneity function of absolute permeability, which is presented in analytical and sectionally continuous function. This function can also be defined from the two arguments, x and y. Dimensionless parameter A of z taking account of heterogeneity in layer thickness, number of layers equals n, is represented by particular probability series in the table of values. This series can be subject to general probability distribution. Then, all computation formulas for modified relative permeabilities of averaged models C and B suggested in the works of Plохотников are mathematically valid, and for this case, absolute permeability function is set as in the first formula. Particular numerical computation was conducted for uniform probability distribution law for the parameter A of Z in a 10-layered oil formation, where N equals 10. Zonal heterogeneity by absolute permeability and average value of formation thickness is determined according to the formulas. The formulas are on the screen. For each of them, zonal heterogeneity K of X changes through the length of oil formation by a factor of 10. Absolute permeability of each of the 10 layers along the upright section is defined by the formula 2. In the calculations, 3 mathematical models of two-phase filtration within the framework of the Buckley-Leverett model were used. The simplest averaged model was model C in the center. It was used for the initial laboratory K sub B of S, K sub H of S, and average absolute permeability by thickness K of X in each upright section of a multi-layer oil field. Together with the model, we used the model B based on correction factors and jet stream displacement scheme. This model worked with modified permeabilities K sub B of S, K sub H of S, obtained on the basis of correction of laboratory permeabilities by particular correction factors. Their formulas were unified for general nonlinear case for laboratory relative permeabilities in the works by Plahotnikov, Bogomolov, and others. We solved the problem of two-phase filtration of a 10-layered strip-like oil reservoir developed in 3 oil wells in a water flood zone. The central oil well pumps water into the reservoir. The other 2, situated symmetrically to the right and to the left of it, produce oil under preset differential pressure. As a result, we get oil displacement completely symmetrical about the center with two-phase filtration. A case of uniform law of setting the parameter A of Z for taking account of stratified vertical heterogeneity of reservoir was considered for variation permeability coefficient V equals 0.55. In calculations, we applied standard functions of laboratory relative permeabilities of water and oil for this type. Here are the formulas. And as for modified permeabilities for uniform law, they can be expressed in terms of the following formulas. You can see them on the screen. Their graphs are presented in figure 1. This is the figure 1, and their modified relative permeabilities.
Colleagues, we have a problem.
Seems to be yes.
Where is the reporter? Where is speaker?
Well, seems to be disconnected. Something.
I think we can wait maybe 2 minutes, and the next presentation can start.
Okay.
Dear colleagues, I'm the next presenter, and while we are waiting for previous one to reconnect, I'd like to ask, can you hear me clearly enough?
Mhm.
Yes.
Okay, thanks. So I'm ready. I'm just waiting for the moderator to announce.
Okay, I think we shall start the second
Yes,
talk.
second report,
Yeah.
because we have no time.
Yes, we have very limited.
Yes.
The next report is automatic recognition of metal smelting quality using machine vision. It's joint presentation. Mikhail Shirobokov, Valery Grishkin, and Artemy Grigoriev. Please. Please start your presentation.
Can you see my screen?
Yes. That's good.
Okay, so let's get started. Hello, dear colleagues. My name is Mikhail Shirobokov, and I will tell you about our research on metal smelting quality recognition using machine vision. So the problem we have been solving here came from steelworks. One of the production stages at which involves transportation of molten metal and transferring it into a trolley. At this stage, an operator using visual inspection should determine how well the melt was made. And in case of detection of substandard condition of the raw material, the operator must take actions to prevent it from reaching the next stage of production. And currently, a human factor plays a significant role in this process. We propose an algorithm that allows to identify possible cases of insufficient quality of raw materials using the video sequence from the camera located next to the place of metal transfusion. And provided video stream is processed in real time. And in the case of substandard material condition being detected, the operator receives a warning. In case of undermelting of metal in a trolley, the combustion process of part of the material is observed. Therefore, the main criterion is that an operator is guided in assessing the quality of the melt is the quantity and the color of flames, as well as the amount of smoke in the working part of the mechanism. The same criteria underlie the work of our proposed algorithm. To facilitate the searching for fire and smoke in the video stream and reduce the likelihood of false positive results before estimating the amount of fire and smoke for each frame, it's first determined if the frame contains the process of metal transfusion or not. The frames significantly differ from each other during the metal transfusion process and outside of it in color and brightness of the image. So for easier separation, the image format of each frame is converted from RGB to HSV. Since the position of the trolley in the frame is known beforehand, we can highlight the informative part of the frame, which is shown in the blue rectangle. And hue, saturation, and value for each pixel are treated as samples of some random variable. Then mean, variance, skew, and kurtosis of these parameters are used as features. Thus, each frame is described with a vector in the 12-dimensional space. Then we apply the Cummins clustering algorithm to it. The resulting clusters adequately reflect reality. Frames at the beginning of the video before the start of this process, and the frames related to the time when the metal has already been poured turn out to be in one cluster. And in another, we have frames belonging to the central part of the video, in which the metal has been poured into the trolley. These points on the left side of the slide, the points corresponding to the frames related to the metal transfusion process are colored in red. And by the way, here you can see the two-dimensional representation of the formed clusters obtained with truncated singular value decomposition. The main point is that such cluster distribution shows us that our choice of features is indeed sufficient for the isolating the desired part from the video stream. And yeah, on the right side, the frame number is represented with a color. The very first frames are colored in dark blue, and the frames near to the end of the video are colored in red. Now, when we have these clusters, we can build a classifier on top of them and use it to determine for each frame if it contains the metal transfusion and should be examined for smoke and fire. Next stage is fire detection. Areas containing fire and smoke can differ greatly from each other during the transfusion of molten metal. Okay. So two different metrics are used to detect them. Since the main criterion for recognizing the bright fire is its brightness, the frame is primarily transferred from HSV color space to grayscale. So essentially, we are working only with value parameter here. In order to reduce the amount of noise, we then apply Gaussian blur to the resulting image. Then it's converted to black and white with a fixed threshold. The dynamic threshold isn't used since the goal is to isolate the brightest area in the image in absolute terms and not in relation to neighboring areas. To further reduce the noise, the image goes to erosion stage, which removes small bright spots, and dilation, which returns large objects approximately to the original size. Then we apply the method of searching for connected components to the resulting image. After removing the background area and the areas that occupy less than 1/500th of the total size of the working area, remaining areas are displayed on the original image. Soft fire and smoke in the video footage have a characteristic red tint and medium brightness, which allows us to select them using a simple filter by HSV parameters. The image sections that fall into the filter are drawn separately, and the ratio of their area to the area of their working region is taken as a metric to estimate the amount of soft fire and smoke in the image. If the amount of fire or smoke exceeds some predetermined value, we make an assumption that there are malfunctions in the process, and the human observer receives a warning, so they could make a final decision. on the material being substandard or not. One of the disadvantages of the proposed algorithm is that the thresholds for amount of smoke and fire cannot be determined in the scope of the method. They should be either derived from a large data set with both positive and negative samples, or obtained from an expert. Another one is noise sensitivity, which is partially handled using the filtering process. However, parts of trolley that significantly reflect light from molten metal are sometimes mistaken for areas of fire or smoke. That's all for the presentation. If you would like to connect us after the conference, our emails are on the screen. Thank you for your attention.
Thank you, Mikhail.
Thank you for your presentation. Any questions?
Mikhail, could you answer, please? What kind of methods did you apply for image processing? Your methods based, did you use neural network approach?
In this case, not. Initially, we were thinking about some kind of convolution network, but it turned out that as we don't need to recognize some shapes on the image, and just in general, we should be able to say if it contains some sort of malformed even shapes like fire and smoke, which can be of any shape. We decided to give it a shot with simpler methods that don't involve neural networks. But well, we could use it in this particular problem in the next stage, when we are asked to determine if, for example, the trolley was correctly mounted to the hook or something.
And I have second questions. How did you estimate precision of your method?
Yes, that's a good question. As I was saying a bit earlier, we still need a data set with positive and negative results to both validate our method on the real data adequately and to get the needed thresholds for our metrics. For now, I used the frames for the from the data set we already have, which is not that much. And some synthetic images where I manually added some fires or smokes on the image. So it worked on it. Well, of course it worked because mostly it's just some portions of the test data with some permutations. But yeah, for now it seems to be working, but I cannot be sure on 100% that it's so, because of the lack of a large data set.
Well, I also have one question about you mentioned IP camera. What is IP? And thermographic cameras or infrared cameras?
No, it's just a regular camera. So the frames I was showing actually are from the camera. That we'll be using. It possibly will have another position, but it will not be some like of thermal essential or something. Just a regular camera.
Okay.
Yeah.
Maybe they will be more efficient. But I don't know.
Maybe, yes. This is just what we got from the Steelworks. If they will have some kind of thermal detection, of course, that will help us greatly, but we haven't one.
Okay, thank you.
Okay. Do you collaborate with some factory to get real?
Yeah, the data we have now and the problem was raised by Severstali. But I'm not the one who contacted them in the first place. Probably Valery Mikhailovich has more information on it.
Thank you.
Thank you. The next report, I think.
Yes. The next presentation, an alternative approach to managing the nitrogen content of cereal crops. The authors are Vladimir Bure and Olga Mitrofanova. Please.
I look at
They are
the
not here.
chat and I cannot see participant. На самом деле, коллеги, вот вчера, по-моему, или позавчера приходило письмо Николаю Васильевичу Смирнову, что они не смогут принять участие, вот я не знаю, значит, не смогут. Там какая-то трагическая история случилась с родственниками. Вот, по-моему...
Дать слово Светлане Никеевой закончить.
Да, давайте тогда так и поступим.
Как раз у нас есть время, пусть они закончат.
Светлана?
Are you here, Светлана?
Она ушла.
I have one more question, maybe to Mikhail.
If you'd like, I could share again the presentation.
Okay. We have time and we can ask you more questions.
Yeah, okay. So,
how many frames in one sequence of images? Approximately.
Yeah. In the one I'm showing you, here is about 5,500 frames, but only about 1,000 of them are related to the process of metal transfusion.
Okay.
I have questions too. Mikhail, could you please, do you have special, for your task, special test collection? And how many picture or images?
Yeah, so the fact is, for now, we have just one complete footage. So it's about, as I was saying earlier, well, 5.5 frames or images. I tried to get some more data from that by permutation of some of the frames and trying to get subsets, so I could perform some kind of cross validation. But well, for now, we have what we have. So that's just one good video. And well, we have some photographs, of course, but they will not help in a way to form some kind of classifier or clustering mechanism or something else. So we get to work with this footage, well, which contains just one process of metal transfusion, and despite there being some quite high amount, well, at least from my preview, at least as far as I can perceive, amount of fire and smoke, the actual workers which send us this video say that is perfectly healthy amount of fire and smoke, and this case is near to ideal. So I don't even have some well-stated negative results to have some thresholds for our metrics.
Thank you for your answer. Professor Elena, maybe we start next report.
Yes, so of course. Yes,
So I can introduce.
Next presentation is last.
Yes.
Okay. So let me introduce you. So
Thank you.
the next speaker is Yelena Kotina. The topic is optimization methods for velocity field determination for tomographic images. This is a joint work by Yelena Kotina, Pavel Bazhanov, and Dmitry Ovsyannikov. So Yelena, please.
Thank you. Okay. Good morning, dear colleagues. Let me present a report dedicated to image processing method that is based on velocity field determination. Nowadays, image processing is becoming one of the most important areas of fundamental and applied scientific research. Mathematical data processing methods are widely used in modern medical diagnostics, which uses a variety of digital imaging methods: computed tomography, CT, magnetic resonance imaging, MRI, single photon emission computed tomography, SPECT, and positron emission tomography, PET. There is a trend toward complete automation of processing and interpretation of medical studies. The automated processing of tomographic images remains a challenging problem. We consider the mathematical processing of image sequences. It is important to obtain information about changes that occur in sequence from one image to another. Detection and correction of patient motion are one of the most important steps of image processing. In this report, we propose a new method for constructing velocity field, which is based on the study of the integral functional on the ensemble of trajectories. Let us consider the system of differential equation 1. We assume that the movement is described by the system 1. Let rho is distribution density function that is a quantitative characteristic of the image brightness, depending on spatial coordinates and time, or intensity of the distribution of radiopharmaceutical for PET dynamic studies. The equation, which for a given vector function f determines the change in the density function in space over time, has the form 2. We assume that function rho is given, and we have to reconstruct function f, which determines the required velocity field. Here, parameter u is considered as unknown. We consider the problem of construction of parameter vector u as an optimization problem. It is follows from equation 2 and 3 that brightness density that the brightness along the trajectories of the system 1 remains constant. And we have the case of the so-called optical flow. Let rho 0 a given density at the moment 0. Rho hat a known density at the moment t. The problem is to find the vector of parameters u that defines the function f so that at the time t, the density distribution calculated by the equation 2 with condition 4 would coincide with the density distribution rho hat. Let M0 the set of initial values for the system 1. X the solutions of the system 1. The set of these solutions is called ensemble of trajectories coming from the set M0 for a given parameter vector u. We denote by MTU cross-section of trajectory ensemble at time t for fixed u. Let us consider the problem of minimization on the solutions of the system 1, 2 of the following functional 7. As function j, we can take the function 8. By minimizing the functional 7, we determine the parameters of the vector u, thereby solving the problem of restoring the function f. Thus, we define the velocity field set by the formula 1. We can write a variation of the functional 7 as expression 9. And on the next slide, we can write the gradient of the functional 7. And based on this functional gradient expression, various methods of directed search for the parameter vector u can be considered. Usually in image processing problem, the form of the function f is unknown, of course. And we consider here the linear case and vector u has the following form, and we can write down the gradient of functional for this case. On this slide, we can see the velocity field determination algorithms based on presented above results. Let us consider the implementation of this method for dynamic PET studies of the brain. This acquisition mode allows us to observe the spatial and temporal distribution of the radiopharmaceutical in the patient's body. We consider the radiopharmaceutical intensity distribution as function of the distribution density rho. Taking into account the discrete nature of the data obtained, we have a sequence of three-dimensional matrices, tomographic images, that display the distribution of radiopharmaceutical in the body. We consider pairs of neighboring images of this series and denote them row 0 and row head. Using the method proposed above, we determine the velocity field at the nodes of a rectangular grid with a step equals to 1 pixel along any axis. The partial derivatives and integrals considered above are also determined by numerical method. On this slide, we can see figures which illustrate the velocity field constructed by this method for human brain PET images for some variants of head movement. And in conclusion, new optimization method for constructing the velocity field for tomographic images is proposed. The implementation of this method on the example of PET brain study is considered, and this method can be applied to correct the movement for dynamic tomographic studies. The development of motion correction method for PET studies became especially important with the development of PET hardware, with the improvement of the spatial resolution of new PET cameras, when motion artifacts became a limiting factor. This method can also be used to correct movement in the different studies of organs and systems of the human body. Thank you. Thank you very much for your attention. Any question, please?
Thank you, Elena. I have a questions. Professor Elena, did you estimate work of your algorithm, of your approach on real data?
Yes, of course. We collaborate with different medical centers of St. Petersburg and Moscow, and of course, yes.
Okay, thank you.
We did it. Thank you for your question.
Well, I also have a question. Well, I'm not an expert, but are there some other approaches, like if we just put a usual camera to detect motions of head or body, and after that to combine the information from usual camera and from PET, from tomographic images to build a picture of motions somehow? Is this approach can be applied?
Yes, sometimes the cameras are used for this purpose, but I think that the proposed method has more accuracy for this purpose, for PET investigation, because first of all, we don't need any other cameras, and we have the full information about not only one frame or some frames from camera, which we did from some raccurse, yes, from some site, but we have the all information about this process when we have three-dimensional image, two-dimensional array of information. Thank
Yeah.
you for the question.
Mhm.
Yes.
Do you have a
we-
questions, colleagues? We have not questions.
Thank you.
Elena,
Yes.
thank you.
I finished my presentation. Two-dimensional. Yes. Мы не слышим вас, Иван.
Sorry. In this session, we have not presentations, and I think we need to close.
Yes. I think we have say thank you for all participants of our session, and we hope to see you again tomorrow morning. Yeah,
Yes.
at the same time, and we hope that tomorrow we will have more presenters, more participants.
Okay, thank you very much, Elena. Now we have a little coffee break, and after that we continue the next session, which called Artificial Intelligence Part 1. Thank you.
Okay, thank you.
Добрый день, коллеги. We can to start the next session. Okay. My name is Ivan Blikanov, and today I'm a moderator of and chair of this section, which called Artificial Intelligence, Part 1. And the next session will be Artificial Intelligence, Part 2. We have in Part 1, we have 4 speakers who will present their talks. All presentations are in English. Not more than 12 minutes are given for every presentation. 2 minutes before the end of this time, I will inform you about this. After that, there will be 3 minutes for questions. During the presentation, the audience will be muted. After the presentation, you can unmute yourself and ask a question. In addition, questions can be asked in the chat, and I will voice them. Also, we have a chat in YouTube, where the live broadcast goes. Let's to start, and the first presentation and report is multilingual sentiment analysis for user discussion on social networks, an approach based on a modified SVM algorithm. Mikhail, could you start, please? Share screen and
yes,
let's go.
okay. Is it working?
Yes, it's okay.
Okay, hello everyone. My name is Mikhail Kukarkin, and I'm going to tell you about our approach on data processing for classification and an enhanced sentiment detection methods based on this SVM algorithm. The amount of textual information on the internet is growing every day, and its analysis becomes more difficult. Text is the prevalent data format on the web, as it is easy to generate and publish. With the development of internet technologies, it became necessary to extract useful information from the text, both for academic purposes and in order to extract material benefits. Recently, the number of active users of social networks has increased many times. For example, according to Statista.com, Twitter has 313 million active users per month. With this number, Twitter has become the source of people's opinions and reactions on different events, topics, news, etc. So one of the major tasks in analyzing text on web is sentiment analysis or opinion mining. It is a class of methods that combines algorithms of computer linguistics, semantic, and text analysis, as well as machine learning in order to eject useful information. Usually, the task of analyzing user discussions comes down to solving a whole chain of separate technical and scientific problems. It primarily includes data collection, which is an interesting task for researchers in terms of creating and optimizing crawling algorithms. Recently, it has become more and more difficult to create a universal collection algorithm, as companies tighten their restrictions on possible attempts to automatically collect user data. The next task after collection may be the structuring and storage of the received raw data. It is necessary to be able to distinguish information by its structure for subsequent correct and simpler processing. Along with structuring, a separate place in the analysis of user discussions is occupied by the thematic classification, so-called topic modeling. One of the stages along with topic modeling is the sentiment analysis of the message or the author, his views and opinions. Sentiment analysis belongs to a separate class of tasks in the field of processing natural languages and is a particular interest of business. The main emphasis of our work is on the creation of combined approaches, including heuristics, knowledge-based, and machine learning. Today, there are three main approaches to solve the problem of sentiment analysis. An approach based on dictionaries of positive, neutral, and negative words, an approach using technologies and algorithms of classical machine supervised learning, and an approach using unsupervised learning algorithms. In this work, we will pay more attention to work with the data before direct classification to show how different approaches can affect the results and what the choice of the text preprocessing algorithms should depend on. The main difficulties arising while constructing the discussion classifier on Twitter social network are the string noise of data and possible intersection of classes. Initially, the data was partitioned into 4 classes: negative, neutral, positive, and mixed. One significant problem of the classification is the high noise level of the source data. For example, if you look at some instances of the sample, you can see that they can only consist of the mention of a user and a link to an internet resource. Such messages do not contain the user opinion in relation to the issue under discussion. In addition, many of the instances contain a large number of hashtags that are common between all discussion posts. This feature leads to a possible retaining of the model on such repeating data. To further improve the accuracy score of multilingual sentiment analysis for user discussions in social networks, the following steps were taken. First, we did the experiments, and they showed that the exclusion of the words from user messages leads to a decline in the accuracy of the classifier. So all stop words are returned to the original dataset. This change made it possible to raise the classification accuracy by 5%. Secondly, the following message characteristics were introduced into the training set. We used the number of mentions of the users and the more accurate determined and the number of links in messages. And third part, we used synonyms to combat noisy data. For each word from the user message, synonyms were selected from the lexical database WordNet. These synonyms, if possible, were selected taking into account the context of the message. The resulting synonyms were added to the text of the original message, and subsequently the classifier was trained on such extended messages. The experiment assessed the quality of the proposed methods of sentiment analysis on noisy data in Twitter and standard text collection using metrics recall, precision, F1, and accuracy. To compare the operation of the algorithms, the public test collection, which is Twitter US Airlines Sentiment, was also used. It is currently used to test algorithms in this research area. This dataset contains user references to 6 US airlines. And it is worth mentioning that all data sets in our experiment were split in test train collections with ratio of 0.2. Despite the complex and unpredictable structure of these discussions, it was possible to obtain very good results for the machine learning approach with the teacher. In both cases, the constructed classifiers showed results much better than random fortune telling for the 3 classes: positive, neutral, and negative. The table shows best results for the data sets. According to this table, the complex structure of social ad hoc discussions noticeably complicates the work of classifiers, unlike the airline dataset that has a similar message structure across itself. Considering classic machine learning algorithms and simple language models, it is necessary to adapt these models to a specific dataset each time. In the future, we plan to compare these approaches using modern artificial neural networks, and we plan to use the same data. Well, that's all.
Thank you, Mikhail. Dear colleagues, do you have questions? I have questions, Mikhail. Why did you choose this test collection for precision estimation?
We used these collections because we work on these projects with our colleagues, and it is the area of interest for us. And to compare our approaches with these ad hoc and difficult discussions, we use public data sets, which is US Airlines dataset.
Okay, thank you. Any questions? I have one question. Are you playing? Are you going to compare with modern approach based on a neural network? For example, transfer learning approach.
Yes, as I said before, we are planning to use the same data for training neural networks and compare our approach with those. And we plan to maybe combine some approaches to get better scores.
Okay, thank you. Any questions? Colleagues, if you have questions, you can add these questions to chat, and Mikhail can answer on this question. Okay, thank you, Mikhail. Now we have a little pause, and in 11:30 we have next presentation, which called on the possibility of using neural networks for the specific problems of meteorological forecasting. After 5 minutes, okay? Thank you. Dear colleagues, let's to continue our session. The next report is on the on the possibility of using neural network for the specific problems of meteorological forecasting. Tokareва Irina and Stankova Elena. Could you please?
Yes, hello.
Hello. Share screen.
Just a minute. Yeah, that works, right?
Yes.
Yeah, good. Good morning, dear colleagues. I would like to present you the talk on the possibility of using neural networks for the specific problems of meteorological forecasting. Modern numerical models are widely used to predict dangerous convective phenomena. Nowadays, this task is very relevant because of the destruction that they produce. Neural networks have already shown their effectiveness in tasks related to such phenomena. For example, generative adversarial network was successfully used to predict typhoon trajectories using satellite images. Therefore, in this work, we explored the possibility of combining the numerical simulation and neural networks to identify the dependence of dangerous convective phenomena development on different convective cloud parameters. This kind of identification is quite important for forecasting thunderstorm with the use of models that do not have block describing electrical processes. Modeling of a convective cloud has been conducted by the use of time-dependent 1.5-dimensional hydrodynamic model with a detailed description of microphysical processes. The picture here shows the interface for the program where the modeling was conducted. On the right, you can see an aerological diagram. In the center, there is a cloud development field, and on the left, there are different cloud parameters. The data for neural network training and testing was collected using the algorithm from the slide. As a result of the implementation of this algorithm, we obtained the dataset containing 416 examples, among which there are examples corresponding to the presence of thunderstorm and those who correspond to the absence of any phenomena. Neural networks, like all machine learning algorithms, depend significantly on the quality of the source data. Therefore, before proceeding to the construction of the network, we needed to prepare the data. First, we normalized the data, and then we selected the most significant features with the help of recursive feature elimination algorithm. On the right, you can see the dependence of the classification accuracy on the number of selected features graph. As you can see from this graph, the maximum is achieved when using 8 features. Here you can see the importance of these features in the current task. Since the multi-layer perceptron is a classical structure for solving the problems similar to that we consider in this work, first we used this type of neural network. The structure of network that gives the highest accuracy was found experimentally and is shown on the slide. Its accuracy is 89.1%. Perhaps such a low accuracy was due to the small amount of data. Therefore, we used one of the methods that helped to solve this problem and increase network performance. It consists in dividing the initial sets of input and output variables into several perceptrons and then combining them into a single perceptron complex. For the first network, the set of features was divided into two groups using a correlation map in such a way that correlated features are placed in different groups. So the accuracy of such network is 90.4%. To improve the result, the original set of features was divided in such a way that two of them are fed directly to the resultant perceptron, as you can see on the slide. The accuracy is higher now and is 91.6%. In addition, we considered two types of networks that belong to radial basis networks because they show good results in problems of binary classification. Also, their advantage is a simple structure where there is only one hidden layer. In the process of training such networks, three sets of parameters are determined. We considered several ways to set their initial values and established how many neurons there should be in the hidden layer to get the highest classification accuracy. So there should be 18 neurons and the accuracy is 91.6%. Also, we considered probabilistic neural network. A feature of this network is that the number of neurons in the hidden layer is equal to the number of examples in the training set. So basically, it's just stores the whole set. The accuracy of such network is 90.4%. In this work, we continued to examine the effectiveness of using machine learning methods for forecasting dangerous convective phenomena on the example of neural networks. We have considered 5 networks, and as you can see from the table, the best accuracy was achieved when using second perceptron complex and radial basis function network. But radial basis function network gave the smallest classification error, and also its advantages over the perceptron complex are simpler structure and short training time. In future, we will further explore the possibility of using neural networks for forecasting thunderstorm and other phenomena, and specifically, our research should be focused on obtaining sufficient number of radiosonde soundings and the corresponding model simulations for training dataset formation. Thank you for your attention.
Thank you, Irina, for your interesting report. Dear participants, do you have questions? Sorry. I have a question. Irina, what size of test collection?
416 examples. Well, we divide, no, for tests.
For tests, yeah.
For tests, something like 80 or 90 examples, yeah, not much.
Okay, and did you, why you did not compare with the classical forecasting time series approach? For example, ARIMA, maybe you know, or Holter-Winters approach. Do you know about these?
Yeah, I've heard of them, but well, it kind of wasn't the aim of this work, I guess. We just, well, we'll do it in the future.
Okay.
Let's say like that.
Because you develop, you use and construct specific neural network, and but there are different classical approach, and maybe classical approach have more good result of accuracy. maybe, but I don't know. But I know that, for example, ARIMA has good result for recasting different task. For example, for recasting currency, currency rate,
Yeah.
or production of different items of company and other. And I think you need to estimate with a classical approach and show this comparison result.
Okay, thank you.
Colleagues, do you have questions?
Yes, can I have a question?
Okay.
Why did we choose to model two of the parameters in one of the architectures, to model them differently when all the others? How did we get which parameters to choose to feed directly to the final layer of a neural network?
You mean this one, right?
Yeah, yes.
Actually, just experimentally. Yeah, I didn't have any specific algorithm. I just experimented.
Empirically approach, yes?
Yeah.
Okay, thank you for your questions. Any question? Okay, thank you, Irina, for your report. And now we have pause about 2 minutes, and after that we to continue our session. Thank you.
Thank you.
Dear colleagues, let's continue our discussion, our session. The next presentation is a metric for comparison of graph theoretic models of the same dimension with ordered vertices. And author is Moskin Nikolai. Nikolai, thank you.
I'm here. Just a moment. Can you see my presentation?
That's good.
My report is metric for comparison of graph theoretic models of the same dimension with ordered vertices. The work is dedicated to methods of comparison and classification of graph theoretic models. This direction is known as graph matching. Methods of graph matching have found application in image and video processing, molecular biology, fingerprinting, recognition of handwriting, and other. A modification of the measure based on a maximum common subgraph is proposed in this paper, which take into account the ordering of vertices. If the graphs have the same dimension, it is shown that the measure satisfies all the properties of the metric: non-negativity, identity, symmetry, triangle inequality. What I mean by graph theoretic models, a finite no empty set of vertices where set of edges connecting vertices, E alpha function that labels the vertices of the graph, beta function that labels the edges of the graph. Where L these values are the sets of labels and attributes of objects and relations respectively defined in a certain subject area, denoted by M, the number of vertices of G, and N, the number of edges of G. One way to compare graphs is using the maximum common subgraph. You can see the first metric, this metric using the maximum common subgraph. And here you can see example of D2, D3, also metric that used maximum common subgraph. The values of D2 are also from 0 to 1, but another similar distance is not normalized for segment from 0 to 1. It is desirable that D satisfies the following properties of metric for arbitrary ijk. You can see non-negativity, the first property, the second property, identity, symmetry, and triangle inequality. For example, a metric D1 satisfies all the properties of the metric. It was shown in paper of Bunke, Horst Bunke. Our modification, now about our modification. When comparing graph theoretic models of text, it is important to consider vertex numbering. Therefore, it is necessary to modify the considered metrics so that they take into account the order of vertices. Let's represent such graphs as a chain of subgraphs generated it, as shown in figure 1. You can see this figure. G1, G2, G3, G4, G5, G6, and G7 is equal to G. You can see this chain. Modification. The distance between graph G and F with the same number of vertices can be found as follows. You can see formula number 5. And let's prove the theorem 1 that this distance D satisfies all the properties of the metric. You can see subgraphs here, Gi and Fi. Prove the first property. Since the number of vertices in the graph Gi and Fi does not exceed I, for all I is equal from 1, 2, so on, m, then this inequality is fulfilled. Therefore, these inequalities also is fulfilled. And you can see it is obviously that the first proof of non-negativity here is fulfilled also. Let's prove the second property, 2 cases. In one case, let D is equal to 0 from G and F. So according to formula 5, we can see that inequalities for all I from 1, so on, m. So these inequalities are fulfilled. On the other hand, these inequalities are fulfilled. So we can see that graph G and F are isomorphic. The second case, let G is equal to F, then obviously Gi is equal to Fi. And consequently, maximum common subgraphs Gi and Gf will have a dimension I. So this equality is fulfilled. So D is equal to 0 according to also formula 5. The third property is true since for this inequality. For all I, 1, 2, 3, so on, m. Let's prove the fourth property. Let H, you can see this graph H in triangle inequality, is a random graph with m vertices. According to formula 5, we can get these inequalities. According to formula 5. Since graph GY, GF, Y, H, I contains I vertices, we can move him from search for the minimum to the maximum. You can see. Then, according to formula 1, is here. We can rewrite this inequality. If the maximum d1 for all I from 1 to so on m is reached for index index, then these inequalities is fulfilled. Therefore, the theorem is proved. Next, this metric can be applied to the task of text attribution in future. Graph theoretic models have been used for a long time in solving the text attribution problems. For example, such a problem arises in the study of the corpus of text from the journals Time and Epoch. It is known that Fyodor Mikhailovich Dostoevsky with his brother Mikhail Mikhailovich Dostoevsky edited and headed these journals. So research has long been conducted on the subject of his writing all these works. So graph theoretic models can be used in such task. In some works, the method of graph of strong links was used to solve these problems. In this case, in graph of strong links, in this case, V is a set of grammatical forms which are found in the text. The number of grammatical forms is determined by specialists of philology, depending on the type of the study. E is a set of strong links of grammatical forms. Two vertices V I and V G of a graph are connected by an edge if the frequency of occurrence of this pair grammatical classes is equal or exceeds the assigned
1 minute.
Yes. A model in the form of a graph with strong links can be also complicated and supplemented. The grammatical forms and their corresponding vertices can be sorted in descending order according to the degree of the occurrence in the certain text. Also, if a vertex does not have incident edges as a result of dropping weak links, it is considered as an isolated vertex. Further, using the measure 5, a matrix of distances between the graphs of a certain text can be constructed. This matrix can be explored, for example, using the multidimensional scaling methods, for example, for identifying hidden factors. In the future, we can be used to this metric to solve the problem of text attribution. Thank you for attention.
Nikolai, thank you for the report. Colleagues, do you have questions?
Yes, can I have a question?
Okay.
So what is exactly a text attribution problem? What task does it try to solve?
Our task is to identify text of Fyodor Mikhailovich Dostoevsky, because in these journals there are a lot of articles without authors. And maybe the authors of the text is Dostoevsky, maybe his brother, maybe Strakhov and Golovachov, Shil, Grigoriev. In this conference, after I think 15 minutes or more, the next the next report was discussed this problem also.
Okay, thank you, Nikolai. I have a question. Did you estimate complexity of these of these metrics, and did you compare with maybe existing metrics? Why this metrics is more best for your application?
The problem of finding maximum common subgraph is hard. Now it is realizing the algorithm for making graphs of strong links in the smart system. Also, I will discuss this program now. About comparing, yes, we did pilot experiments, and our experiments, there are a lot of not a lot of experiments, maybe few experiments, and our metrics really show difference between metrics. This metric is more good than metrics, for example, this. We compare with this metrics. Also, some also we compare with this metrics in some examples. Excuse me, my English is not so good.
Okay, thank you, Nikolai, for your report. Now we start the next presentation, which called topic models with neural variational inference for discussion analysis in social networks. Nikita, please share screen, and you can start. Your microphone is muted.
Okay, so let's begin. Topic models. Topic models and their extensions have been applied to many fields, such as marketing, sociology, political science, and digital humanities. They analyze documents to learn meaningful patterns of words, which can be helpful and useful in a wide variety of natural language processing tasks, such as information retrieval, hot words extraction, statistical inference, multilingual modeling, and others. And one of the most interesting and applications of this type of models is the task of identifying and analyzing user discussions in social networks. In this application, a topic model, given a corpus of user messages, can output a set of distributions which can clearly identify them. This can be helpful for identifying key points of discussion, performing summarization, clusterization, both as independent model and as part of a larger system, in conjunction with other models, such as sentiment analysis, for example. However, traditional topic models have some downsides while analyzing user discussions. The issues include poor processing of short text, ineffective analysis of noisy data, and inability to work with multilingual data. Traditional models can be used to solve these issues by using specific auxiliary datasets, which can usually consist of graph information of relations between words. However, or translation techniques in the case of multilingual problem. However, these solutions introduce new variables that not only cause computational cost increase, but also introduce new variables and as such reduce the resulting quality of models. So in this paper, we are mainly concerned with 3 different types of models. There are multiple ways to address common issues of traditional topic models, ranging from simple preprocessing techniques to fully developed methods designed to work specifically for short text. One of such model is a bitom topic model. It is an algorithm which applies inference process very similar to that of latent directly allocation, which is a very popular topic modeling algorithm. I'd say the most popular algorithm even today. As you can see on this plate notation, the key difference of this algorithm is the direct usage of word co-occurrence patterns in bitom topic model, which makes the original data much more diverse and produces much better result when applied to short text commonly found on social network. As a preprocessing step, this model constructs a set of bitoms, which can be thought as a simple pair of words commonly occurring together in the same context. Previous work with this model has shown its effectiveness compared to the baseline LDA model and another modification of its inference process, Word Network Topic Model, or WNTM for short. It employs another way of altering the original data by creating a fully connected word network, moving away from document to word space to space which encompasses all words. Previous work has shown that results obtained using bitom topic model are more interpretable in terms of automatic coherence measures, and therefore, in this study, it was chosen as a baseline. Another type of modification done to LDA model is the idea of instead of using underlying set of topics, identifying an underlying set of topics using mean field variational inference, to use the neural network to parameterize multinomial topic distributions. There are 3 proposed variants of this neural network architecture: Gaussian softmax, Gaussian stick breaking, and recurrent stick breaking. The last one is applied in this case to effectively model textual data. A recurrent stick breaking construction uses advantages of recurrent neural networks to effectively model all sequences of textual data. And the last model we are concerned in, or we are studying in this paper, is embedded topic model, or ETM for short. It differs from classic approaches like LDA in its newer, more robust implementations like bitom topic model and neural variational document model, in that it uses the embeddings to represent both words and topics. This allows the model to learn topics and word similarities without using any external data by directly modeling their representations. Prior to the discovery of such models, like I said, usually external graph information on word similarities was used, but instead this model uses CBOW, a type of language model which, given a list of surrounding words, can output missing word in a sequence based on their likelihood. There are 2 main use cases of this model. It can either learn embeddings as part of its inference process, simultaneously obtaining embeddings for topics, or using previously fitted embeddings provided by another model. The most obvious advantage of this model is modeling words not present in the training data. Another advantage is robustness in terms of stop words and vocabulary. It simply bypasses this issue by recognizing the place of stop words in embedding spaces and putting them all into a separate topic. One of the model-based model ideas of ETM is using the pre-trained model, pre-trained word embeddings. There are a variety of ways to learn these vector representations, from classic context-independent methods such as word2vec, GloF, and FastText, to context-aware state-of-the-art models such as XLNet, BERT, and Elmo. FastText is a model which learns word embeddings by utilizing subword information. It not only increases the performance compared to the baseline approaches such as word2vec, but also accommodates for words not present in the training data, which is a property very desirable in the task of analyzing social networks. Elmo is, on the other case, is a 3-layer neural network. It consists of a character-level convolutional neural network, in that its first layer is context-independent, and second and third layers allow the model to predict word information using the context of words in that sentence. In our case, well, it's important to note that it's impossible to use context-aware models such as ELMO to their full potential due to the structural limitations of ETM, in that it requires uncontextual word embeddings. However, due to the sparsity of data use in this case, averaging over word embeddings in different contexts can provide a meaningful improvement over standard models such as word2vec, fast text, and other context-independent methods, as it will be seen in the experiment. Described models are tested on 3 distinct datasets using different coherence measures. The results are plotted to find best performing and most consistent topic models. The datasets used here are 2 of them are tied directly to the main task of this study, is analyzing user discussions on social networks. One is multilingual, based on multiple big events and user opinions on them, collected from Twitter. Another one is from Twitter on one language, and the last one is News20, which is a very popular set to test textual models and is very well studied and used in a variety of tasks. We are using 2 different metrics, topic diversity and coherence. Topic diversity can be thought has the intuition that the more diverse and unique words different topics have, the better the underlying model will be. And normalized point-wise mutual information, NPMI, is a very popular metric to test textual models, which uses relations between words and sentences. We are plotting a composition of them with a much bigger weight on NPMI score, because diversity is a property which is only necessary in some part. In these results, we can see that in the News20, the default dataset, the ETM outperforms standard approaches by a sizable margin, but not in all cases. However, here we can see the topics obtained by it using the ELMO pre-trained embeddings. For example, here topic 1 corresponds to sports, topic 2 corresponds to writing, and etc. However, in the case of a Twitter dataset, it can be seen that the difference between model is especially big for ETM combined with different pre-trained embeddings. Mainly due to the usage of pre-trained multilingual models for such embeddings. In conclusion, and also here, we can see the different topics obtained for this dataset. Some of the words here were in different languages because the dataset collected was using English, French, and Russian languages. But here, all of the words are translated, and it can be seen that the topics obtained are coherent and diverse. In conclusion, the experiment shows that a combination of embedded topic model and pre-trained embeddings obtained by ELMO vastly outperform traditional topic models, for example, Bitom topic model in the task of analyzing short and unbalanced text, such as user messages on Twitter. Even if used without any customization, it learns the most diverse and coherent topics. It is worth mentioning that word embeddings can be reused to optimize the software for user discussion analysis in social network. In such softwares, topic modeling is just one part of the whole system, and obtained topics and embeddings can be further used in the downstream tasks, such as sentiment analysis, for example. Future work mainly involves implementation of model that can take full advantage of context-aware embeddings from models such as BERT and sentence-level encoders, such as Universal Sentence Encoder. We are also interested in a more broad task, text summarization, with its own unique approach to this type of problem, taking other models, both traditional clustering models and models specifically designed to model messages, can provide a deeper insight for this task. Thank you for your attention.
Nikita, thank you for your interesting report. Colleagues, do you have a question? Okay, I have a question. Nikita, can you tell me, please, why did you use 3 test collection? What is the principal difference between the Twitter test collection and top news? Yes, top news. Maybe I incorrectly call.
News
But why
20.
difference? What you mean? What you want to show us where you take this test collection?
So Twitter datasets are obviously the main part of this study because it's part of our project with journalism department of our university. We are working on identifying key topics, key position on certain arguments. So we chose these datasets as an example because they are datasets obtained from social networks. So they have, as I said, some key differences between classical datasets, such as, for example, collections of papers, because they have specific language used. We have more in terms of short text. We have more useless information, like for the most part, useless information. So and some other interesting meta information, for example, hashtags, dates of posting, offer, and etc. And News 20 was chosen as a baseline dataset, which can be used to compare different models and is commonly applied to, I'd say, academic field when we need to compare models on a baseline on some common dataset.
Mm-hmm. Okay, I saw that in top news test collection, the result of your approach and baseline approach, not big difference, yes.
Yes,
But
yes.
in more noisy information, you have more efficiency of this algorithm, of your algorithm, yes?
Yes. That's, yeah, like I said, that's due to the usage of News 20 dataset is only English and consists of very defined sentences, very defined topics. So it's much easier to discern them from this dataset. However, in Twitter dataset, it's much harder, not only due to the language used, but also due to the fact that the discussions are in multiple languages sometimes. For example, some of the discussions are in French, English, and German, for example, and other languages simultaneously. So the pre-trained word embeddings for multiple languages can provide a much better result in this case.
Thank you for answer. Any questions? Okay, we have questions. Thank you, Nikita. Now, second part of this track is end, and now we have 15 minutes, a pause about 15 minutes, and the next session will start in 1:30 p.m. And first report is data crawling approaches for user discussion analysis on Web 2.0 platforms. Thank you, and see you again. Hello, dear colleagues and dear conference participants. Now we continue last session, session TB3, which called Artificial Intelligence Part 2. My name is Ivan Blikanov. I am a moderator and chair of this section. Last session has 3 presentations, 3 speakers who will present their talks. All presentations are in English, not more than 12 minutes are given for every presentation. 2 minutes before the end of this time, I will inform you about this. After that, there will be 3 minutes for questions. During the presentation, the audience will be muted. After presentation, you can unmute yourself and ask a question. In addition, questions can be asked in the chat, and I will voice them. Also, we have a chat in YouTube live channel where the live broadcast goes. Let's to start, and first report of last section is data crawling approach for user discussion analysis on Web 2.0 platforms. Dmitry Nepiyushik. Dmitry, are you here?
Yes, yes.
Thank you. Please to start and share your presentation.
Good day for everyone. Currently, the number of network users is more than 4 billion users. The audience of social networks is more than 30 billion. In 2090, about 1 million users start using social networks each day. It's about 11 new users per second. By the fact, the large number of users explain Web 2.0 class platforms as social networks, messengers, and open repositories. Due to the involvement of users, their high activity in content generation and technological features of Web 2 class platforms, we can observe a high rate of dissemination of information about any events in social networks. What about the relevance of the work? All points on the page are very connecting. Some researchers need to analyze data for their own purposes, while sociologists need data to analyze social opinion and mood. It's also important to highlight suspicious activity in social networks, but in general, getting data is important for solving SNA problems, which is data crawling, sentiment analysis, topic modeling, and bot detection. Current research in data crawling on Web 2 has several approaches for data crawling from Web 2 class platforms. It's using ready-made databanks, using ready-made software, data crawling based on API, and the own web crawling approaches. Let's look at each type in a more detail. When using an approach based on ready-made databanks, we can face a number of problems. It's data completeness, data authenticity, data integrity, and data relevance. And very important, it's the data bank resources are not free to use. When using an approach based on using ready-made software, it's impossible to evaluate the completeness and integrity of the information received. The tools for data the tools for data crawling in the Web 2.0 platform are not free to use either. When we use data crawling based on API, we have some problems. It's not always possible to guarantee the authenticity and integrity of data. But it's worth noting that this approach is mostly used when collecting data from the services that have an AP. Relevant platforms can provide various types of AP access. It's a fully accessible API, for example, it's Telegram AP, partially accessible API, for example, Yandex Maps AP, and fully paid API, for example, it's job search service Headhunter AP. When working with any kind of AP, it's necessary to be aware of the restrictions that the corresponding services can impose on the data crawler. It's query frequency, query uniqueness, various identifiers of devices, and the privacy of the data collected. When we use own data crawling approaches, we have two approaches. It's solution based on simulating user activity in browser or application, and solution based on requests to the platform server. As for solution based on simulating user activity in browser or application, it's important to understand that the speed of data crawling is comparable to the speed of user activity. When receiving content, need to download the HTML page, all media, and CSS. When simulating actions in a mobile application, the process of obtaining data becomes even more complicated and longer due to the exchange of commands at the device level and possibly the instability of the connection. As for solution based on the request to build such a data crawler bot, it's necessary to differentiate platform traffic and fully emulate all service requests. On this page, presented a general scheme of data crawling. The scheme included a downloader page, queue for query, scheduler for query, parser for data, and tool for saving in storage. Focused on Telegram data crawling and Facebook data crawling. As for Telegram data crawling, its scheme is represented on the page. The scheme includes data downloader, model for checking account, account for blocking, a model for request generation, but it's important to highlight the module for requests generation includes two sub-models. It's a model for generate noise requests and a module for necessary requests. Also, the scheme includes a parser for data received from Telegram messenger and tool for saving data in database storage. Own Telegram data crawler based on Telegram API implemented by Python and Pyrogram library. Introduction of the additional model for generate noise request is caused by the fact that data crawler must generate extra requests to bypass the security policy manager. Because it was said previously, it's necessary to observe query frequency and query uniqueness. Certainly, it's needed to monitor blocking account, and when they are blocked, need to create a new account. For this was implemented module for checking account for blocking and a module for creating new account. As for Facebook data crawling, then it was implemented in two ways, but general scheme of data crawler for Facebook presented on the page. The scheme included following models: data downloader, model for checking account for blocking, module for create new account in Facebook, model for checking subscription to community, model to subscribe to community, requests generation model, model for parsing data, tool for saving parsed data in database storage. Let's review both ways in details. First way, based on simulating user activity in a browser. This data crawler implemented by Python and using Selenium library, also based simulating user activity in Google Chrome browser. However, this approach we might meet several issues. With a large number of posts in the community, might happen memory overflow. This is due to the fact that creating a browser environment or content from Facebook download in memory, and after that data processing starts. Also, with a large amount of data, the parsing time increases, and a large amount of data, the speed of getting data is decreasing. Second way, based on REST user activity, this data crawler implemented by Python and using library requests and using JSON for easier data access. There are obvious problems here. High complexity of development, because at least one incorrect request may lead to account being blocked. They need to constantly monitor Facebook for change in the logic of generating the corresponding requests. Necessary constantly to monitor traffic of web version Facebook or a mobile application Facebook. Also, it's important to note the advantage of this way, high speed of data acquisition and processing. Data collection in the way occurs without loading HTML page and all content of the page, getting only JSON with metadata which characterize all content from the page. It's enough to limit yourself to small computing resources, since data size is not large and each time we get only a new partition of data, then the processing takes less time and requires less resources. What about experiment? Experiments setup, during the experiments in social networks and messengers, there was a large involvement of audience in the problem COVID-19. We identified communities from Facebook and chats from Telegram Messenger after the data acquisition process was started. Facebook and Telegram data collection issues. The following problems were observed during the data collection process. Temporary restriction on the operations of accounts, blocking of accounts through which data collection occurs, and blocking the IP address through which data is collected. These problems were solved thanks to the use of proxy, the introduction of noise requests, and more polite work on data crawler. On this page, we can see the results of the experiment. As you can see from the table, a large amount of data was received in a reasonable time. Data from Facebook was collected in 2 types data crawler. The difference in time spent is caused by the fact that way data collection from Facebook based on simulating user activity in a browser comparable with the real work of the user. In results, it was implemented data crawler for Facebook based on REST. This method requires less computing resources, but its high complexity of development and harder to maintain. Necessary using proxy, noise request, and configure the courtesy of data crawler. What about Telegram data crawler? It's enough to limit Telegram API since the speed and completeness of the data is accessible. They presented Facebook data crawler can help in research in the scientific community as it makes it possible to automatically obtain a large amount of data in a reasonable time. Thank you for your attention.
Dmitry, thank you for your report. Colleagues, do you have questions? Okay, I have a question. Dmitry, tell me us, please. I know that Facebook has a strong policy of data access, of user data access, and you talk about you create special setting for your crawler which can help you to crawl information about user publication and user content in a different community in Facebook. I know that it's hard task, and can you tell what is currently settings? How many thread your crawler has, and what is the timeout between thread? Can you show details?
Okay. in my data crawler, I use one thread for collecting data from Facebook, and this content I collecting for one thread. Time pause in each request is random integer value. It's time less than 1 second each request.
Okay.
And if we want to collecting more data, we can add some thread in the data crawler very quickly.
Now you have not multi-thread downloader of your crawler, yes?
No, I have multi-thread, but I want to collecting data in one thread. It's very important for me. I testing my data crawler in one thread.
And why? What is the reason?
I want to check my data crawler how many data I can receive from Facebook in one thread, and
okay.
For reasonable time, because 90 hours it's a very reasonable time for this for number posts collecting or number users collected.
Thank you for your answer. I have question. I know that you crawl information from different social network, for example, Facebook. Yes. What is legal process? This process is legal or not?
I collecting data from Facebook. I collecting open data. It's posts in community. It's user info, open user info. Not I want to hack user page and collecting private information. It's maybe email address or mobile phone users. It's legal because what can see user on the HTML page in browser or mobile application, I receive this information.
Okay.
For researching, only researching.
Thank you for answer. Any questions, colleagues? Okay, we have not questions. Thank you, Dmitry, for your report. And the next presentation is characteristics of lexical spectra of texts in the problem of establishing authorship. Author are Moskin Nikolai, Kulakov Kirill, Rogov Alexander, and Abramov Roman. Could you start?
Yes, just a moment. Так, почему-то не могу включить демонстрацию. Другой участник не выключил.
А кто? Нет, вроде все выключили у нас. А кто не выключил?
Сейчас попробую еще раз. Вот все. Окей.
Thank you.
Can you see my presentation? Yes. You can see my slides, yes?
Yes, it's good.
So my report is characteristics of lexical spectra of text in the problem of establishing authorship. When solving pattern recognition problems, a number of features can have a rather complicated structure. For example, a certain attribute may be represented by a graphical model, a histogram, and so on. However, when solving the problems of clustering and classification, For example, in task of text attribution, the features should be uniform. This is especially important when using decision trees or random forests. Therefore, it is required to replace a certain characteristic with a single value. Some articles from the magazine's Times, which were edited by Fyodor Mikhailovich Dostoevsky, you can see that this report is connected with my previous work, were taken for our analysis. 9 of them, as an author, have the dubia mark. It means that these are works supposedly attributed to one or another author. Regarding to the rest of the works, it can be said with certainty that the author is either Fyodor Mikhailovich Dostoevsky or Nikolai Strakhov, for example. The works were divided into fragments of 500 words. If a text fragment has less than 500 words, then it is excluded. A total number of fragments is 149. Famous researcher in the field of text attribution, Hitso, note that it is possible to research the stylistic handwriting of the writer also from the point of view lexical spectrum of a text. You can see two characteristics: lexical spectrum at the dictionary level, F, we note it F, and the lexical spectrum at the text level, we note it MF. All lexical spectrum is set based on a frequency dictionary of a text. It is necessary for comparison to extract data from samples of the same length, 500 words. Here you can see the definition of lexical spectrum. Table 2 on next slide shows the characteristics of F and MF for two texts. One text of Dostoevsky, one text of Strakhov. You can see this table. This is for of Dostoevsky, this is of Strakhov. On the next slide, figure 1 shows.
Sorry, what is for example 167? What do you mean? Sorry.
What this 116?
No. Second column text. Yes. For example, this value. What is mean?
167.
Yes. On next, what is?
Yes. You can see definition of this spectrum. All the word forms were divided into separated groups based on the frequency of occurrence M. 1, 2, 3. You can see 1, 2, 3, 4, 5. Then the program determines
the frequency of word. How word presence in text?
Yes.
For example, we have term 1, term 2, term 1. We have term 1 is 2 times, yes, term 2 1 time.
Yes. Maybe Alexander, my colleague of philology, can help to ask this question.
Sorry, okay, you can continue. Sorry. sorry.
This is the philological term. So maybe he after a report more detailed set about this distributions. So you can see this diagram, frequency of occurrence M and lexical spectrum, dictionary level. This is frequencies. Как объяснить-то? If the frequency is 1, we can count how much words include in this group and other. And it's clearly noticeable that as the parameter M increases, the value of attributes decreases. I think it is clearly. So in Petrozavodsk State University, SMALT system is developed, and with the help of these systems, we get this spectrum, lexical spectrum. The construction of lexical spectra requires preliminary processing of text. This is achieved by dividing texts into blocks of the same length and building a lexical spectrum for each block. In addition, the construction of the lexical spectrum at the dictionary level is based on the initial form of the word. There are algorithms for automatically determining the initial form of a word based on the structure of the word or using the database of word. However, under the condition of using text fragments of pre-revolutionary journals, this approach is not applicated. Maybe my colleague can also describe the problems of pre-revolutionary orthography. Within the framework of the SMALT information system, SMALT is statistical methods of the analysis of literary text, SMALT, that we are developing in Petrozavodsk State University. We are analyzing both textual works by philologists and analyzing textual works. Text works go through 3 steps: import, verification, and analysis. During the import, the text product is divided into paragraphs, sentences, and words. Each word is compared with one of the existing morphological analyses. If it is impossible to select a morphological analysis for work, then it is marked. And in the second step, the text is checked by philologists. So the help of philologists is necessary. And analysis of text works is performed by a group of individually. In a group analysis, the researcher selects one or more textual works and the block size. As a result of group analysis, Excel tables is formed containing the lexical spectrum of each block. Short text and incomplete blocks are ignored. When analyzing a single text product, the researcher can choose the block size and the indent from the beginning of the text to build lexical spectra of the block. Then next, the use of multidimensional methods to solve the problem of text attribution requires a diagram to be represented by a single characteristic. These diagrams with a single characteristic. This dependence can be approximated by hyperbolic curve and exponential curve.
2 minutes.
Parameters can be found using the least squares methods. We will analyze which of the characteristics can be used to represent lexical spectra in the text attribution problem. To test the hypothesis, we found a Pearson correlation coefficient between these models and the distance chi-squared in the diagrams. You can see how to calculate the 1 and how to calculate the 2. This is a distance chi-squared. As the calculations showed, the Pearson correlation coefficient was this value. According to scale of Cheddak, such a relationship believed notable. In the table 4, you can see different correlations or different coefficients. If we similarly consider the second coefficient b, then the correlation between D2 and D3 is equal to 0.68 about. Another type of relationship is shown by the exponential curve. Correlations will be weak. You can see here that it is rather weak. It means that these characteristics don't reflect the structure of lexical spectrum. If they consider another linguistic statistical parameter, MF, lexical spectrum at the text level, the contrast between the coefficient of two types of regression is even more noticeable. All the values in table 4 showed statistical significance. Let us consider in more detail the coefficients A and B. You can see Pearson correlations for text fragments that consist of 750 words and 1,000 words. You can see that these correlations are greater. The values for A and B show statistical significance. According to the scales of Cheddak, this correlation is high. For text fragments consisting of 1,000 words is very high. Very high. You can see high and very high. It is also clearly seen that the correlation for MF in all three cases is slightly higher than for F. This suggests that characteristics A and B better approximate the lexical spectrum at the text level than lexical spectrum at the dictionary level. Using the analysis of some 133 text fragments, the characteristics A and B were calculated, and then a decision tree was constructed. You can see this decision tree. You can see A, you can see there is no B, what this B you can see. And it can be concluded that this feature is not very significant for solving this classification problem. However, it can be used to solve the classification problem by the random forest method, along with other features, as we do in our other works. For example, it may be the frequency of occurrence of certain part of speeches, n-grams, average sentence length, and so on. Conclusion. The obtained results were presented for further consideration to the specialists of departments Russian language and Department of Classical Philology, Russian Literature and Journalists of Petrozavodsk State University, and it can be used for solving such significant problems as determining the authorship of article Poems by Khomякov, who is an author Apollon Grigoriev or Fyodor Mikhailovich Dostoevsky. Also, this approach can be used to solve the problem of distinguishing folklore texts from text stylized as folklore. Thanks for attention.
Nikolai, thank you very much. Dear participant, do you have questions? Okay, I have a question. Correctly, I understand that you want to identify author.
Yes, yes.
Okay. Your approach, is your approach universal?
Yes, we can use these characteristics A and B for another tasks. As an example, I said a few words about folklore texts. They works with this problem also. Really folklore text, folklore songs, and stylized folklore songs with an author. And I think that this approach can be used with in another problems. It is universal, I think.
Okay. And you can apply your approach only for literature text, or you can, for example, apply methods for user message. Because, for example, literature text is long text. Yes?
Yes.
We have many words. We have a big statistic. We can crawl big statistic about how author present information. But, for example, user message in Messenger, in mobile phone, in social network have specifics. No, for example, shortly text, many noisy information. How your methods stability if we work with noisy and shortly text?
Yes, it is very interesting questions. Such experiments, maybe we can divide it. If the user message is short,
for example, one sentence, maybe two maximum, two sentence.
I think it is really small for our methods. One sentence. I try to imagine lexical spectrum of such short text, and I think that diagrams I don't know. Now I can't say quickly how diagrams what we get diagrams on the diagrams. It's a really interesting question.
Okay, need to test, yes.
Yes, for our future analysis.
and pass and will pass experiment. Okay, thank you, Nikolai. Any questions?
I have no question, but I can add some information connected with that report.
It's my offer.
Oh, okay.
May I do it?
Yeah.
Okay, I am a co-author of this report and of this project, and actually the question on the answer on the last question is it's more difficult to divide the text on the lexical spectrum of the small text. Actually, the bigger the text, the easier is to divide it and to use this information in research. Texts that are small, one sentence, two sentences, three sentences, it's very difficult to use this material in the project, in this research. And the question was about lexical spectrum and the meaning of these numbers. Actually, these numbers 1, 2, 3, etc., up to 10 plus is a number of occurrences, which means how often some words occur in the fragment. For example, number 1 means that some word took place in this fragment only once. It's only once in this fragment of 500 words. And 10 plus is this means that this word take place in this fragment 10 place numbers. It's very often usable words. Such words as e and other prepositions, conjunctions, and so
on. Thank you very much for detailed answer. Let's start the next presentation, which called Research of Feature of Dostoevsky Publicistic Style by using n-grams based on the materials of the time and epoch magazines.
Just a moment. Just a moment.
Nikolai, you will present this report again?
Yes, yes. It was planned that my colleague Roman Abramov will present this report, but he can't. So I do this report with my colleague Alexander Lebedev. Research of features of Dostoevsky's. Can you see my presentation, colleague?
Yes, we.
Research of features of Dostoevsky's publicistic style by using n-grams based on the materials of the Times and Epoch magazine. You can see that this report also is connected with my previous reports. Our collective is Roman Abramov, Kirill Kulakov, Alexander Lebedev, Nikolai Moskin, Alexander Robov, Petrozavodsk State University. The report is devoted to the research of the publicistic style of Dostoevsky based on articles in the magazines Time and Epoch. The authors of text, in addition to Fyodor Mikhailovich, are his brother Mikhail Dostoevsky, Strakhov, Golovanchov, Shil, Grigoriev, Grigoriev, Paretsky, Polonsky. There are in this research 19 texts in total. 12 of them belong to Fyodor Mikhailovich Dostoevsky and 7 to other authors. The size of a single text is at least 1,300 words. Note that some other articles from these journals still don't have an author. I said about this earlier. Therefore, this work should be considered in the context of a broader problem, attribution of text. Attribution of text of Dostoevsky, it is a fundamental problem in philology. Fundamental problem in philology. Maybe Alexander can add more about this. establishment of authorship of an anonymous text. You can see source texts, Dostoevsky, Grigoriev. This is a fragment of table fragment. You can see code, you can see journal, year, and so on. This problem has been declared in the philological community for a long time. It is really a fundamental problem. It is for the reason that there is a need to use methods that are not quite traditional for literary studies. Mathematic methods and computer technologies can be used to solve this problem. The specificity of this study is that the analyzed texts are presented in a pre-reformed orthography, which makes it necessary to create new or modernize existing approaches. By itself, the orthography in the middle of 19th century implies a certain variability of spellings, which complicates the automatic processing of sources. But at the same time, it better allows to trace the features of the individual author styles demonstrated in the construction of the text at its different levels. This analysis is based, this is a new approach, based, if we compare with my other reports, based on taking into account grammatical and morphological features, namely the distribution of part of speech, not lexical spectra, but distribution of part of speech within the analyzed text, which should also be considered a distinguishing feature of the work of a particular author. N-grams, what is it? In our research of text, n-grams is a sequence of n elements encoded parts of speech. And we constructed these n-grams for different texts and their fragments. The small system helped us to do it. I earlier said some words about this system. Specialists in philology carried out grammatical markup of text, which took into account 14 parts of speech. You can see these parts of speech. Noun, adjective, and so on. So the texts were analyzed use bigrams, bigrams at 2 gram or bigram, synonymous, as follows. The fragment size 500, 700, and 1000 words, and the step 100, 200 words, etc. were allocated to select the beginning of the next fragment. You can see that some fragments can русские пересекаются. No, some fragments can have similar parts. Then the frequency of occurrence of n-grams in text will be calculated. The constructed fragments were analyzed using with decision tree. As a result of their consideration, it turned out that a tree of depth 3 is sufficient to determine the morphological features of the publicistic style of Fyodor Mikhailovich Dostoevsky and other writers. It is very interesting. You can see a decision tree that was constructed with the help of bigram. Step 100 words, fragment 1000 words. This figure, on this figure, you can see decision tree for 3 grams. 3 grams, step 100 words, fragment 1000 words. when we change the size of text fragments of size of sample, we can get a lot of decision trees. Decision trees G1, G2, and so on, Gn. That differ from each other. At the same time, they are united by the fact that they are oriented binary trees where each vertex is associated with a certain bigram or trigram, and also is associated with Gini index and threshold value. To research the features of Dostoevsky's publicistic style, it is important to understand how text fragments and decision trees derived from them are related. It is important for philologists interpretation. For this, we can carry out a comparative analysis of these trees. You can establish a measure of similarity D on a set of trees. In my previous report, I show some measures to do this. After the necessary calculations, a matrix of distances between trees is obtained. The first experiment showed that the trees obtained from closed tree-roots are similar to each other. The differences are manifested in the threshold value for the same features. At this moment, we can say that this method is quite stable. However, additional experiments are required to get recommendations for choosing the step size and fragment size. So this work in future continues. Conclusion. Among the experiments, the weakest results were shown by decision trees with a fragment size of 500 words. On decision trees with a depth 3, the accuracy was always less than 89%. The most stable result, it is also important, the most stable result showed fragments of 100 words. This size. Most frequency accuracy is 93%. The step size significantly influenced the accuracy. However, this is rather due to the number of analyzed fragments. You can see different accuracies for different fragments. Of course, this is also a fragment of table. The table is rather big. If we consider a classification at the first level of the three fragments, fragment size 1000, then the accuracy was on average 87%. This feature is the percentage of the presence of bigram adjective noun, this bigram. Table 4 provides information about the value of Gini index. Let's see this table. Gini index and bigrams, different bigrams, or different trigrams. Then constructing decision trees for other steps, the value of this attribute changed insignificantly. In the second and subsequent steps, the decision trees used different bigrams after changing the step. This indicates the less stability for solving the classification problem, we can say about it. Note that among the incorrectly classified fragments of the articles that don't belong to Fyodor Mikhailovich Dostoevsky, the first and last fragments predominated. I think Alexander can say some words about this interesting fact, which may indicate the editorial correction of Fyodor Mikhailovich. Editorial correction. The final slide. Another trend was observed in the analysis of trigrams. They shared the text words. Such conclusion we get. To achieve the same accuracy, a tree of greater depth were required. At the same time, better results were obtained on trees with a fragment size of 500 words, thus increasing the size of the fragment worsened the result. The most significant feature at the first level was trigram noun, adjective noun. Thanks for attention.
Thank you, Nikolai. Colleagues, questions?
Actually, I have no questions, but I can add some philological information about this project, about this research. And if we have time, I can add this aspect of...
Okay, but I have question.
Sorry.
I have. Did you use only decision tree for classification, and why?
In this work, really only decision trees, but we planned to use random forests also in the future. Why we use decision trees? Because decision trees clearly for philologists. Philologists can analyze decision trees. When we make, for example, neural networks, philologists can't understand how it works. So.
Okay, thank you. When you processing your text, you construct bigram or n-gram in general, yes?
Yes.
And correctly understand that you use information only one orientation of bigram, trigram, for example, from left to right.
Mm-hmm.
You don't use from right to left.
For example, noun, adjective, adjective, noun.
Term 1, term 2, term 3. Yes, it's trigram, for example. But also additional, I know that exist different techniques about text processing, and modern methods use not only one way, one orientation in text processing, but orientation from right to left. It's additional information. Did you use this specific,
yes.
or you? No, for example, participle, second line.
Maybe what adjective, noun, adjective.
Adjective, and if you, it's left from right when you parse a term, yes, but you can use information from right to left. Adjective, noun, participle.
Maybe Alexander can say some words about this as a philologist.
Actually, we were not using from right to left methodic, only from left to right.
I understand, but now there are many special techniques which can help get new hidden information. Yes, new hidden dependency between word, between for example, between different part of word, different type of word, and its style. Yeah, yes, a style how author write a message or create texts. And for example, the next my questions about punctuation marks. Did you use or you cut this information?
Punctuation marks were not used at all. They were cut at the moment of parsing of the text.
But we lost. but you lost information because maybe author like stay different punctuation marks.
Maybe, but actually this research was connected only with parts of speech, only with lexics, not with punctuation, not with syntax. Maybe it's the other step which we will going to make in other researches. But now only parts of speech, only lexic.
Did you estimate maybe hard connectivity words? Well, for example, which word contains of two words? It's сложносоставное слово. Did you use this information about?
You mean such words as красно-белый and so on, which are?
Yes, maybe красно-белый.
Красно-белый is one word. So we when we were parsing the text, this word was counted as one. Only some words with.
I mean, сложносоставное слово, да? Вот, то есть это слово, которое состоит, например, больше, чем из 6 слогов. То есть автор любит излагаться, например, такими вот, ну, сложносоставными словами, непростыми, да? Там.
In this research, we were not taking this into account. Actually, it's only about parts of speech. There are some other methods. Some other methods include the quantity of letters in the word. And in this case, actually, it's we can see one author prefer to use small words, another author prefer to use big words. And it's an information which we can take into account and use in our research. But in this research, this information was not used.
But I think if we use many parameters,
yes,
different, yes, we can get more accuracy result.
Yes,
with big precision.
Yes, the more parameters we use, the more the cleaner are results. But this research is only about parts of speech. Actually, in some time we will take all of the parameters and parts of speech and the quantity of letters in the word and the lexical spectrum and so on. But this was a research only connected with parts of speech, not with other parameters.
Okay, thank you. Any questions? Alexander, you can expand presentation. Maybe you have additional information.
Yes, a bit philological addition about a problem. There are a lot of anonymous articles in Russian literature, and for example, in our journals, in our research journals, Time and Epoch, Время и Эпоха, about a half of articles are not identified, are anonymized, And for every philologist, it's very important to know who is the author of a text. We prefer to work with the text with the identified author. So that's why this is a very important problem. And the mathematical methods allow us to clearly understand that that article is devoted to Fyodor Mikhailovich Dostoevsky. Another article is devoted to Mikhail Mikhailovich Dostoevsky, his brother. A third article is devoted to Apollon Grigoriev, and so on. And it's very important in the theory of literature, in the literature criticism, and so on. That's why we try to use some researchers connected with mathematical technologies, and it's very important to it's very important for philologists to answer to these questions. That's it.
Thank you, Dmitry, for your answer. Dear colleagues, now we have not presentation. Our section is end, and I hope that we can meet, and maybe you want to go and to visit YouTube channel tomorrow. Tomorrow we have two sections, two track. Sorry. I have additional information by tomorrow. Medical and biological system control, control and optimization, and electrophysical process, and other topic you can listen tomorrow. And today we have not a report, and I think our session is very good. And see you again, maybe a different conference in the future. Thank you and bye.
Thank you. Bye.
Thank you.
Thank you. Bye.